Feedback Madagascar has an active drilling programme to construct boreholes in rural regions of Madagascar where access to potable water is limited. This video provides a brief summary of the process of constructing a borehole from start to finish. Households must often collect water from unclean sources far from the village. Not only does this take time and energy, but it is a large cause of waterborne pathogen transmission. Only half of the households in Madagascar use an improved water source, and diarrheal disease is the leading cause of morbidity and mortality among young children. Village committees may meet to discuss ongoing water issues and consider asking Feedback Madagascar for assistance in constructing a borehole in their village. A letter is written on behalf of the village and sent to Feedback Madagascar. A pre-feasibility visit is then undertaken by the team to determine if it will be possible to drill a borehole, which often depends on geology, sanitation and village population. If it is possible, the team begin the journey along often long and difficult roads to transport personnel and equipment to begin the drilling. The journey can take up to 2 days for very rural regions, often requiring the crossing of rivers and even using pirogues in some places, followed by long treks to remote villages. The team arrive with the equipment. Then a technician will run an initial workshop with the village to explain the drilling process, how the Kanzi pump is designed and how to use it. They will also explain the best practices for maintaining a sanitary and efficient borehole. Once a suitable location has been chosen for the borehole, the site is blessed by village elders to improve the look of finding water, and hopefully not too much rock. After this, it's time to begin. The hole is started with a shovel, and then an auger is used which twists soil out of the ground. This can be used down to about 3 meters, after which the borehole is likely to collapse and a more sophisticated method is required. This method is called jetting and involves cycling water through the drill rods and into the hole, where it maintains a waterlogged hole and removes drilled soil. The water pressure prevents the hole from collapsing. A team of 4 drillers rotate the drill rods with a sharp drill bit to work their way through the ground. When hard ground is encountered, the technique can be adapted to break up the rock. This method is called Rotasludge drilling and is used when especially hard rock is encountered, as it is better at impacting the rock and breaking it up. No motor is needed to cycle water, as soil and rock are removed by taking advantage of the downstroke of the drill rods. A driller keeps a hand over the top to form a vacuum on the upstroke and removes it on the downstroke to draw up water. Beneficiaries help by collecting water from nearby rivers. The water is stored in large containers for use by the drillers. The drilling often continues to between 10 and 20 meters. Here, the cycling of water using the motor pump can be seen. Water is mixed with biodegradable polymer to thicken the water and prevent borehole collapse. Geology is recorded as drilling progresses. If the technician is happy with the amount of water encountered and the geology is suitable, the drill rods are extracted, ready for borehole construction. The borehole, made from PVC, is designed by the technicians and drillers and then constructed. Lengths of correct sizes are joined by partially melting them and placing them together. When the PVC cools, it forms a very tight bond. The end is melted to create a cap for the bottom where no sediment can get in. At the correct section, 1 mm thick slits are sawed into the PVC, which allows the water to enter but prevents larger sediment from doing so. In the meantime, gravel is collected from nearby rivers to create a filter pack around the PVC. Gravel is cleaned, sieved and transported back to the borehole, where further sorting takes place to ensure only gravel of the right size is used. Too big and it will not filter the water, too small and it will enter through the slits in the PVC. The PVC pipe is lowered into the open hole. Angled slits towards the bottom can be seen here if you look closely. This process is done in 2 to 3 sections, gluing together each section as it is lowered into the hole. The gravel pack is emplaced around the PVC. This allows for filtering of water while also increasing borehole stability. Development of the borehole then takes place using a rope pump to extract water, a surge block to cause surges of water in and out of the borehole, and a motor pump to inject water into the hole. In their own way, each method increases the clarity of the water by gradually removing sediments in the aquifer and gravel pack. It also opens up cracks in the formation, which increases water recharge. The Kanzi pump is then installed into the PVC borehole. The pump uses a one-way valve to gradually lift water up the pipe with each downstroke of the pump handle. Cement bricks are made, which are used to construct the closure surrounding the borehole and support the wooden fence. The closure is mostly to prevent animals entering, improve sanitation, and clearly mark where borehole rules and regulations begin. Meanwhile, a 3-day training course is given to the future borehole committee by the social technician. The committee will be in charge of maintaining rules and regulations and ensuring the borehole is successful and as long-lasting as possible. A successful committee is key to a successful borehole. A sanitary apron is made from concrete. This allows excess water to escape from the closure and prevents water from forming puddles, which allow bacteria to contaminate the area. It also improves the aesthetic quality of the borehole and generally increases cleanliness. A soakaway is dug just outside the closure, into which water can escape and infiltrate back into the ground. The fence is painted with a waterproof coat to protect it from the elements and make it look better. A final round of developing occurs using the Kanzi pump. This ensures the final water quality is acceptable and free from sediment. A hand washing facility is also constructed. And voila, a finished working borehole. The water is tested for bacterial contamination to ensure it's safe, and a minimum of 3 chlorination rounds are done to sanitize it. And then it's time for celebration. The drilling program started in 2009, and boreholes drilled back then are still in operation today. Of course, there are some problems that are encountered, but these are often resolved with action from the borehole committee, and we stay in touch with each committee to offer support when it is requested.
Sakelin mama tiki mirata fala yeluku misavo sakelin mama umalala na dade alatini anenyo azafati zukibe mama makani teno hanila yavakwe